We covered a basic ionic bonding the other day with a simple positive charged ion and a simple negative charged ion, and we saw how they kind of match together almost like a puzzle piece, so we can determine how many of each atom we need in order to balance those charges so that the compound that's formed is neutralized, so there is no more charges. So now we're going to talk about when we use a metal that has more than one charge option. And so I had you guys go through your periodic table, and we were looking through the different elements on the periodic table that have more than one charge option. So the charges are up in the top right hand corner, and we can see, for example, that tin, number 50, has a charge option of +4 and +2. So we're using today thallium and chlorine together as an example. So thallium is number 81 on your periodic table, and it has a charge option of +1 or +3. That means that thallium can react two ways with different elements that it bonds with. That means that it could have one electron if we were to draw a Lewis dot diagram in its outer shell. Oops, sorry. So we could have one electron if it was thallium 1, or if it was thallium 3, it would have 3 electrons in its outer shell. Okay? So what that means is that when it bonds with something like chlorine, chlorine is number 17 on your periodic table. That means that it has a charge of -1. So it's looking to get one more electron in its outer shell to fill its outer shell. So if it were to bond with thallium 1, and it has 7 in the outer shell, it would look something like this. And it's a very easy 1-to-1 ratio. And that's where we get TlCl. So there's one atom of thallium and one atom of chlorine. And when we're naming it, which is the part of what we're doing today, we're going to use a Roman numeral system. So we've taken a list of Roman numerals, and if you don't have those, you can come and get those from me in class. But the Roman numeral for number 1 is like an I, like a capital I. In this case, if we were to bond chlorine with thallium 3 instead of thallium 1 and put a 3 there, it would look something like this. So here's the difference. The problem is that if we just had one chlorine atom bonding with the one thallium 3 ion, it wouldn't work, because we still have this electron and this electron that need to bond with something else. So those are outstanding and they need to bond with other things. Now, if this were any atom, we could throw in something else. We could throw in an oxygen, because oxygen is a -2 valence. It's number 8 on the periodic table. We could throw in a hydrogen and a fluorine. We could do all kinds of different things. But in this case, because we're talking about thallium chloride, the only atoms that we're allowed to have, or the only elements we can have, are thallium and chlorine. So if that's the case, then we have to keep including more chlorines into this molecule until all of the outer shells are full. So we need one more still. This is what thallium 3 would look like. So because there are 3 electrons in its outer shell, it needs to have 3 chlorine atoms to match up with it, because each chlorine atom can only take 1 electron. And this one here, thallium 1, it's an easy 1-to-1 match, because there's 1 here and chlorine needs 1. So we name it with a Roman numeral.